Webb reveals dust and water forming right next to the Milky Way's central black hole, defying expectations for such a harsh environment. This is Fascinating Frontiers, episode 158. An international team used the James Webb Space Telescope to find dust and water surviving close to the Milky Way's supermassive black hole. The evolved star IRS-3 continues releasing newly formed material despite intense radiation from the central region. These observations show material can form and persist in environments previously considered too hostile. The findings come from mid- and near-infrared imaging that isolates the star's contribution from the surrounding glow. Webb's sensitivity allowed astronomers to separate the star's output from the bright background of Sagittarius A itself. Additional spectra will help determine the exact temperatures and densities where the water molecules remain stable. Now, shifting from the extreme environment around a black hole to the more familiar but still intricate structures left by ordinary dying stars. Webb captured the planetary nebula in mid-infrared light, highlighting the complex structure of swept-up gas. Lower mass stars like the one that formed the nebula shed outer layers instead of exploding as supernovae. The white dwarf at the center is ionizing an expanding bubble of gas that forms the lion's face and destroys dust in its path. Ongoing research focuses on how these rings and shells develop in nebulae of this type. The mid-infrared view isolates the heated dust and ionized gas without visible light confusion from foreground stars. Follow-up observations will track changes in the bubble's expansion and dust destruction over time. A typical planetary nebula spans roughly 1 light-year across, about the distance a commercial airliner travels in 200,000 years of continuous flight. When a sun-like star exhausts its core hydrogen, it swells into a red giant and then ejects its outer envelope in successive pulses, spaced centuries or millennia apart. The exposed hot core, now a white dwarf, floods the ejected gas with ultraviolet photons that ionize it and drive a fast wind outward at hundreds of kilometers per second. That wind sweeps up earlier, slower material into dense shells and rings whose spacing records the timing of each ejection episode. Temperatures in the ionized zones reach tens of thousands of degrees, while the shells themselves expand at only 20 to 30 kilometers per second. Slow enough for astronomers to watch structural changes over decades with repeated imaging. The same central star can produce both intricate multi-layered patterns and simple spherical shells depending on the mass loss history and any binary companion that may be present. Yet the precise combination of factors that decides which outcome occurs in any given nebula remains unknown. From the shaping of planetary nebulae to another case where Mars's surface history is being rewritten, new analysis challenges the long-held view that the Martian surface froze solid around 3 billion years ago. Evidence suggests liquid water could have persisted later than previously modeled, altering timelines for surface habitability. Researchers examined geological indicators that imply episodic melting or groundwater activity after the presumed global freeze. Further orbital and rover data will test whether these conditions lasted into more recent epochs. The revised chronology rests on re-examination of valley networks and mineral deposits previously dated to earlier periods. Models incorporating these observations now allow for brief intervals of surface liquid after the main freeze-over. From past water on Mars to the rover now climbing toward a key geological boundary in Gale crater. The rover is approaching a large-scale erosional supersurface in Gale's sedimentary record that marks a shift from net deposition. Planning for Sols 4968 through 4974 focuses on characterizing this feature through targeted imaging and contact science. The supersurface records a period when environmental conditions changed across the crater floor. Scientists will compare rock textures and chemistry above and below the boundary to understand the transition. MASTCAM and ChemCam observations will document layering and mineralogy at multiple scales along the climb. The data will help reconstruct how long the change in depositional regime lasted and what caused it. From surface exploration on Mars to statistical searches for ice beneath it. Two studies from the Planetary Science Institute now assign a 64% probability of finding ice beneath specific patches of Martian mid-latitude ground. The work moves beyond simple consistency checks with orbital data to probabilistic assessments. Targeted digging or drilling at high probability sites could test the predictions directly. Results will guide landing site selection for future ice access missions. The probability maps incorporate both neutron spectrometer data and thermal inertia measurements from orbiters. Sites with the highest scores also show morphological features consistent with ice-rich material just below the surface. From Mars subsurface prospects to rare alignments that let astronomers weigh distant galaxies. A neural network scanned a catalog of 800,000 quasars and identified 7 cases where the host galaxy lenses a background object. These alignments allow astronomers to weigh the quasar host galaxies despite the bright central engine drowning out starlight. The method bypasses the usual difficulty of separating quasar glare from galactic mass. Follow-up spectroscopy will confirm the lensing geometry and refine mass estimates. The 7 systems represent an extremely small fraction of the input catalog, underscoring how rare the required alignments are. Each confirmed lens will provide an independent mass measurement for its host galaxy at a time when the quasar was actively accreting. From clever data analysis to an algorithm now scheduling entire telescope nights. The algorithm learned from years of actual astronomer decisions rather than following predefined scheduling rules. It now selects targets that maximize usable data given weather, moonlight, and atmospheric conditions. Early tests show the system reduces wasted time on marginal observations. Continued training on new nights will improve its ability to anticipate changing conditions. The model was trained on logged observations from multiple facilities, capturing patterns that human schedulers had developed through experience. Real-time updates allow the system to reprioritize targets when clouds move in or seeing deteriorates unexpectedly. From software optimizing observations to hardware that can be shipped anywhere for launches. The portable launch system fits all required infrastructure into standard shipping containers for rapid deployment. GHOST is designed to support neutron and electron operations from new sites with minimal fixed construction. The approach aims to increase launch flexibility and geographic options. Initial demonstrations will validate transport, setup, and countdown procedures under field conditions. Each containerized module contains power, communications, propellant handling, and safety systems needed for a complete launch campaign. The design allows a launch pad to be established in weeks rather than the months or years required for traditional fixed facilities. From portable launch capability to a Canadian operator already booking it. The Canadian operator has reserved multiple flights on Rocket Lab's upcoming medium-lift vehicle for optical relay satellites. The first dedicated mission is scheduled for 2028. Kepler plans to use the launches to expand its next-generation constellation architecture. Contract details confirm payload capacity and orbital delivery requirements. The optical relay satellites will provide high-bandwidth data links between other spacecraft and ground stations. Neutron's larger fairing and lift capability compared with Electron will allow Kepler to orbit heavier, more capable platforms in a single launch. From commercial launch contracts to an astronaut preparing for her first spacewalk, ESA astronaut Sophie Adenot will join NASA astronaut Anil Menon for U.S. Spacewalk 97 on 18 August. The pair will replace a space-to-ground antenna on the International Space Station to maintain high-speed data and voice links with Houston. Coverage begins at 1300 Central European Summertime, with the spacewalk starting around 1435 Central European Summertime. Live streams will be available on ESA Webb TV and the ESA YouTube channel. The antenna swap is required because the current unit has reached the end of its operational life after years of continuous service. Ground teams have already prepared the replacement hardware and verified all tools for the extravehicular activity. From human operations in orbit to recent rocket successes and setbacks on the ground, Japan's H3 launched the 10,800-pound Michibiki 7 satellite from Tanegashima on 10 August. The spacecraft will support regional navigation services from a high Earth orbit. The mission marked another operational flight for the H3 vehicle following earlier tests and demonstration launches. Ground teams confirmed successful separation and initial acquisition. Michibiki 7 joins an existing constellation that augments GPS coverage over Japan and surrounding waters. The satellite's mass required the full performance of the H3's enhanced upper stage for the transfer to its final orbit, from a smooth Japanese launch to a Chinese failure the same week. The rocket broke apart less than 90 seconds into flight from Wenchang, carrying a rumored military communications satellite. Public footage captured the explosion during first-stage ascent. Chinese state media have not yet released an official statement or failure analysis. Investigations will examine telemetry to determine the cause. The failure occurred while the first stage was still burning, before any planned staging events. No injuries or ground damage have been reported from the launch site. From launch outcomes to new ways of sharing space content with the public, continuous NASA content is now available on Discovery Plus live channels, with special events including Artemis 3 also streaming on HBO Max. All broadcasts remain freely accessible on NASA Plus and social platforms. The expanded distribution aims to reach broader audiences beyond traditional viewers. Program schedules will continue to include mission coverage and educational segments. The partnership brings live mission commentary and documentary programming to platforms already used by millions of households. NASA Plus will retain the complete on-demand archive and real-time mission feeds without subscription requirements. From audience reach to opening mission software to outside coders, the agency invites coders worldwide to contribute and run software on the spacecraft during its asteroid encounter. Selected experiments will execute in deep space aboard the Hera probe. The initiative expands community participation in mission operations and data analysis. Proposals will be evaluated for technical feasibility and scientific value. Hera's onboard computer resources allow multiple guest experiments to run alongside the core mission software. Successful submissions could demonstrate new autonomy algorithms or data processing techniques in the actual radiation and thermal environment of deep space, from open spacecraft software to the final weather satellite briefing. Journalists can register for online briefings in English, French, and German ahead of the Meteosat third-generation Imager satellite launch. Applications close 17 August. The sessions will cover mission objectives, spacecraft capabilities, and launch preparations. The satellite will enhance European weather monitoring from geostationary orbit. MTGI-2 carries an advanced imager that provides higher resolution and more frequent observations than previous Meteosat generations. The briefings will also address launch vehicle integration and expected post-launch commissioning timeline. Keep an eye on the first results from those global developer experiments once Hera reaches its target asteroid. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. One more thing, if you liked today's episode, our sister show Models and Agents for Beginners is worth a spot in your feed. Artificial Intelligence Explained Simply for beginners and curious teens. It's one of the NERA Network's daily briefings, all free at neranetwork.com. Live dashboards, TSLA, SpaceX launches, the investing scoreboard are all at neranetwork.com/data. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.